Hello, good morning. I'm discussing about linear combination of atomic orbitals, principles of molecular orbital theory. The wave functions describing molecular orbitals are obtained by a method called linear combination of atomic orbitals, LCO. The wave function describing the molecular orbitals are obtained by a method called linear combination of atomic orbitals. Molecular orbitals are formed by the linear combination of atomic orbitals molecular orbitals are formed by the linear combination of atomic orbitals. Linear combination of two atomic orbitals, wave functions are brought about by addition and subtraction overlap of atomic orbitals. Let psi A and psi B are the wave functions of two atomic orbitals. A and A plus B, AB, psi A, psi B, psi molecular orbital. When two atomic orbitals overlap, the new wave functions psi AB and molecular orbitals psi MO is formed and can be obtained by linear combination of atomic orbitals psi N, psi B. Psi AB equal to n C1 psi A plus C2 psi B. N is the normalizing constant which ensures that the probability of finding electrons in the whole space C1 and C2 are the constant which gives the minimum energy for psi AB. The probability density for the combination of two atoms is given by the square of the wave function. Psi square equal to n C1 psi A plus C2 psi B squared. Opening the square, if n equal to 1 to C1 square psi A probability finding of electron A to C2 square psi B probability finding of electron B to C1 C2 psi A psi B overlap of two atomic orbitals. The larger to C1 C2 psi A psi B, it is the stranger is the bond between A and B when there is higher electron density and the internuclear region and bond is stronger. There will be two molecular orbitals, result of two types of combination. Psi bonding molecular orbital, psi A plus psi B, psi anti-bonding molecular orbital, psi A minus psi B. Equation 3 represents formation of bonding molecular orbitals. It is formed by addition overlap of atomic orbitals, that is, overlap of atomic orbitals having the same sign. Question 4 represents the formation of anti-bonding molecular orbitals. It is the form by subtraction of molecular orbitals. Subtraction of overlap of atomic orbitals, that is, overlap atomic orbitals having the opposite sign. Features of bonding molecular orbitals: it possesses lower energy than atomic orbitals from which it is formed. It has higher electron density than two nuclei and stable. It is formed by combining atomic orbitals having the same sign, but magnitude of psi B is always bigger than psi A minus psi B. Every electrons in a bonding psi molecular orbitals contributes to attraction between two atoms. Features of anti-bonding molecular orbitals. It possesses higher energy than the atomic orbitals from which it is formed. The probability of finding the electron in between the nuclei is negligible. It is formed by the loops of combining atomic orbitals of opposite sign. Psi star is numerically smaller than psi over psi b. Every electron in an antibonding molecular orbitals contributes to repulsion between two atoms. Higher energy, lower energy atomic orbitals. This is the molecular orbitals. This is the bonding and this is the anti-bonding. Rules for linear combination of atomic orbitals. The combining atomic orbitals should have roughly the same energy. The overlapping orbitals must approach each other closely enough for considerable overlap to form molecular orbitals effectively. For producing bonding and anti-bonding molecular orbitals, either the symmetry of two atomic orbitals must remain unchanged when rotated about the internuclear axis, or both the atomic orbitals must change symmetry in the identical manner. For producing bonding and anti-bonding molecular orbitals, symmetry of two atomic orbitals must remain unchanged when rotated about the internuclear axis of or both the atomic orbitals must change symmetry in the identical manner. Thanks for watching. Thank you for your patience. Let us know. Bye bye. So again.